Hello everybody, welcome into another lesson. So today we are going to talk about quadratic functions and graphing them. So everyone by now should be familiar with quadratic functions. In the standard form of a quadratic function, you have f of x equals ax squared plus bx plus c. Now, in this general standard form, to find the coordinate of the vertex, which is either going to be the maximum or the minimum point of the parabola, because a quadratic function produces a parabola. The x-coordinate is the negative of b over 2 times a. And then to find the y-coordinate, you'll just stick the x-coordinate value into the quadratic function, you'll get the y-coordinate. Now, if your leading coefficient a is greater than 0, the graph of the parabola rises to the left and rises to the right. If your leading coefficient a is less than 0, if it's negative, the graph falls to the left and falls to the right. So that's how you would handle a general form equation, and then you have also the vertex form, where you have f of x equals a times the quantity of x minus h to the second power plus k. The vertex form is nice because it straight up gives you your vertex. You set x minus h equal to 0, you get the x coordinate of the vertex being h, and then that k is your y coordinate. So that form makes it real easy to find your vertex. Now, we have to also, when graphing these, it's also helpful to find your x and y intercepts. To find your x-intercepts, of course, you're going to set your quadratic function equal to 0, and then you'll solve for x. And again, those may be methods such as factoring or completing the square or the quadratic formula. You could even use the graphing calculator, but today we're just going to stick with everything but the graphing. So I'm going into this lesson assuming that you know how to find the zeros of a quadratic function. If you're unsure how to do it, please review Algebra 1 and 2 where I talk about solving quadratic functions. There's no shame in that if you need it, but by now, I'm assuming since you're in pre-calc, you have a good grasp on how to solve quadratic equations. So let's get started with our first one here. So let's say you have f of x equals x squared minus 7. So you have f of x equals x squared minus 7. So first thing you probably want to do is find the vertex. This is in general form. So the x-coordinate of the vertex is going to equal that negative of b. Well, your b term is 0 because you have no coefficient with x to the first, so that'd be negative of 0 over your 2 times a. Your a coefficient is 1 over 2 times 1, which of course would just give you 0. Now, if you put in 0 into the function, so take f of 0, you would get 0 squared minus 7, which would just give you negative 7. So your vertex in this case would actually be 0, negative 7. So let's go ahead and plot 0, negative 7. Alright, so here's 0, negative 7 down here. Now, it's helpful to find your intercepts. Well, your y-intercept occurs when x is 0, so it just so happens your vertex in this case is also the y-intercept. So we do have a y-intercept at 0, negative 7. Now what about our x-intercepts? That occurs when y is 0, so we'll set this function equal to 0. So take that x squared minus 7, set it equal to 0. That would give you x squared equals 7, which should give you x equals plus and minus the square root of 7. So you have x-intercepts at both plus and minus the square root of 7, 0. So knowing all these now, let's go ahead and graph this thing. And let's get an approximate value of the square root of 7. I know it's going to be a little less than 3. So what is, in fact, the square root of 7? That's about 2.65. So that's going to be right about here, and then right about here. All right. So we've got our x and y intercepts in our vertex, so now let's go ahead and graph this. And there you go. There is the graph of f of x equals x squared minus 7. And that leading coefficient was positive, meaning this is going to rise to the left and rise to the right, which means to the left of the vertex and to the right of the vertex. Now, had this been negative x squared minus 7, then we would have a whole different situation on our hands. So, in fact, you wouldn't even have x-intercepts. You would end up having an absolute maximum at 0, negative 7, but this is your absolute minimum at 0, negative 7. Because your vertex in this case is an absolute minimum because it's down at the bottom of that valley. And I got plenty more of these. All right. F of x equals half of x squared minus 4. So we have f of x equals half of x squared minus 4. Well, let's find the vertex. So x always equals the negative of b. Well, we have no x to the first term, so right away x is going to be 0. Now let's put in f of 0, which would just give us negative 4. So the vertex of this parabola is going to be 0, negative 4. All right, now in this case, again, let's try to find y-intercepts. That's when x is 0. It turns out in this case your vertex is also your y-intercept. That's going to be at 0, negative 4. So let's go ahead and plot 0, negative 4. That would be right there. All right. Now, it's also probably a good idea. Let's identify whether it's going to rise or fall. That 1/2 is going to be positive, right? So it's going to rise left and right. So that means you're going to have an absolute minimum at 0, negative 4. Now, last thing, let's find the x-intercept. So take that half of x squared minus 4, set that equal to 0. You'll get half of x squared is equal to 4, which would give you x squared equals 8, which would give you x equals both plus and minus 2 times the square root of 2. So your x-intercepts can be found at plus and minus 2 times the square root of 2, 0. So let's go ahead and plot our x-intercepts. Let's figure out what 2 times the square root of 2 is. That's about 2.83. So negative 2.83 right about there, positive 2.83 right about here, and now let's go ahead and plot these. And then here is my graph of f of x equals half of x squared minus 4. Based on the vertex, the y-intercept, and my 2 x-intercepts. And since it's a quadratic equation, that would make sense that I'm going to actually end up having 2 x-intercepts. All right. f of x equals the quantity of x plus 4 squared minus 3. So we have a quadratic equation in vertex form. So this is going to straight away give us the vertex. The vertex in this case is going to be, if you take x plus 4, set it equal to 0, you'll get x equals negative 4. So your vertex would be at negative 4. Your y-coordinate would be at negative 3. So you have a vertex at negative 4, negative 3. So 1, 2, 3, 4, 1, 2, 3. Here's your vertex at negative 4, negative 3. Now let's look at the coefficient outside of the parentheses, your a. It's a positive one. Since your coefficient is positive, that means it's going to rise to the left and right. So it's good to understand what the end behavior is going to look like. Now, a y-intercept is going to be, of course, when x equals 0. So your y-intercept will definitely be x equals 0, which would give you 16 minus 3, which would be 13. You'll be somewhere all the way up here. So y-intercept is going to be at 0, 13. It'll be off the chart, so we probably don't even have to worry about graphing it. And then let's find the x-intercept. So set your function equal to 0. So this would be x plus 4 quantity squared minus 3 equals 0, which would turn into x plus 4 quantity squared equals 3, which would then give you that x plus 4 equals plus and minus the square root of 3, which means x would equal negative 4 plus and minus the square root of 3. So your x-intercepts can be found at the points negative 4 plus and minus the square root of 3, 0. So let's plot our x-intercepts. Let's take the square, let's see, negative of the square root of 3 minus 4, that puts you at about negative 5.73, about right there. And then what about for negative 4 plus the square root of 3? That puts you at about negative 2.27, which would be right about here. So now that we have the intercepts, let's go ahead and start plotting. And there is the graph of this particular parabola, where you have x plus 4 squared minus 3 equals f of x. All right. F of x equals the quantity of x minus 6 squared plus 3. All right, so we have f of x equals x minus 6 squared plus 3. Well, again, it's in vertex form, so if you set that x minus 6 equal to 0, you'll get an x-coordinate of 6 for your vertex. And then you have that plus 3, so your y-coordinate is 3. So the vertex can be found at 6, 3, which would be right here. There's your vertex. Now, let's look at that coefficient. That coefficient, of course, is going to then end up being 1. It's a positive 1, so it's going to rise to the left and right, which should start becoming plain to see. You're not going to have any x-intercepts because it keeps rising. This is actually not going to intercept the x-axis. In fact, if you tried to set this function equal to 0, you would get x minus 6 squared equals negative 3, which we know the square root of negative 3 would be plus and minus I times the square root of 3, and there's no way to graph that in the real plane, so we don't have x-intercepts. So let's write that, no x-intercepts. Now, how about y-intercepts? Again, that occurs when x equals 0, so you would get negative 6 squared plus 3. That would give you 36 plus 3. That'd be all the way up at 39. So the y-intercept would be at 0, 39. All the way, way up in the ceiling there. So let's go ahead and graph this. And there is the graph of x minus 6 squared quantity plus 3. Alright, this changes. We have x squared minus 8x plus 16. So we have x squared minus 8x plus 16. Well, we can find the vertex right off the rip. It's going to, of course, the x-coordinate of the vertex is equal to that negative of b, which would be positive 8, over 2 times your a. Well, 2 times a is 2 times 1, that's just 2. So that means your x-coordinate is 4. So now, to find your y-coordinate of the vertex, put in that f of 4. What's that going to give you? 4 squared is 16, minus 8 times 4, which is 32, plus 16. Well, 16 minus 32 is negative 16 plus 16 is 0, so your vertex can actually be found at the point 4, 0. So here's your vertex. Now what about your end behavior? The coefficient on this function is a positive 1, so it's going to rise to the left and right. Alright, and then so we do technically have one y-intercept. If you want to, one x-intercept, because x squared minus 8x plus 16 is going to factor, let's set x squared minus 8x plus 16 equal to 0. Well, this actually factors into x minus 4 quantity squared, which again would just give you x equals 4 with the multiplicity of 2. So the x-intercept is also your vertex. That's going to be at 4, 0. Then your y-intercept, you just set the x is equal to 0. You would get a y-intercept at 0, 16, which would be off the chart. So the y-intercept occurs at 0, 16. So your graph is going to look something a lot like this. So there is your parabola, x squared minus 8x plus 16. That one wasn't too bad. F of x equals x squared plus 2x plus 1. Let's actually talk about the end behavior first. The coefficient on the x squared, your leading coefficient, is positive 1. So it's going to rise to the left and right. So it rises left and right. So now we know the end behavior. Next thing's your vertex. So you have, of course, the x-coordinate of the vertex equals that negative of b, which would be negative 2, over 2 times a. That'd be 2 times 1, which is 2. So your x-coordinate is negative 1. Now to find the y-coordinate of the vertex, let's make this f of negative 1. Well, negative 1 squared is 1 plus 2 times negative 1. Well, that's actually minus 2, excuse me. Then you have a plus 1. Well, 1 minus 2 is negative 1 plus 1 is 0. So your vertex is actually going to be found at the coordinate negative 1, 0. So here's your vertex at negative 1, 0. And then, of course, x-intercepts, it turns out this is the only x-intercept, because if you set x squared plus 2x plus 1 equal to 0, this factors into x plus 1 squared equals 0, which means your only x-intercept is going to be at the point negative 1, 0. So your vertex is also your x-intercept. Now what about your y-intercept? Put in 0 for x, you'll get a y-intercept at 0, 1. So the y-intercept can be found at 0, 1. So let's go ahead and plot that point and draw your parabola. And there is your parabola with your vertex at negative 1, 0. F of x equals negative x squared plus 2x plus 5. Alright, so we have f of x equals negative x squared plus 2x plus 5. Well, let's start with the end behavior first. Notice this time the coefficient, the leading coefficient, is negative 1. Since it's negative, for the end behavior, it'll fall to the left and right. So this parabola falls left and right. So we're going to have an upside down parabola. Alright, now let's work on the vertex. So let's see. X would end up equaling, of course, the negative of b, which is negative 2 over 2 times your a of negative 1, which is also negative 2, which would give you an x-coordinate of 1. So to find the y-coordinate, put in f of 1, that would end up giving you negative 1 plus 2 plus 5, which would end up giving you 6. So the vertex can be found at the point 1, 6. So here's your vertex at 1, 6. Alright. I think it's going to be easiest to start with your y-intercept. That's when x is 0, so you would get a y-intercept at y equals 5. So the y-intercept occurs at the point 0, 5. We can plot 0, 5, which is going to be right here. Alright, now let's look for x-intercepts. So we got to set this negative of x squared plus 2x plus 5 equal to 0. And uh-oh, this does not factor very nicely. But we can complete the square. First, let's factor out a negative 1 from both sides. You would end up getting x squared minus 2x minus 5 equals 0. So to complete the square, you'll have x squared minus 2x. Alright, half of negative 2 is negative 1, plus that squared is plus 1. That's going to equal 5 plus 1. So you would end up getting x minus 1 squared would equal 6. X minus 1 would equal plus and minus the square root of 6. So your x-intercepts will be found at 1 plus and minus the square root of 6, 0. it's better than using the quadratic formula. If you can, try to use completing the square, because we all know the quadratic formula is not particularly fun. Alright, so let's see. That would put your first x-intercept at about negative 1.45, so about right here. Whoops, I'm off a little bit. There's about negative 1.45. Alright, now what about for the other x-intercept? So let's see, square root of 6 plus 1, that'd be at about 3.45. About right there. So now let's go ahead and draw this graph. And there is your graph with the vertex found at 1, 6, with all the various intercepts that we have. So knowing your intercepts and your vertex, all those things, and the end behavior helps you understand what you're actually graphing. It makes your life with graphing so much easier. F of x equals negative x squared minus 4x plus 1. Alright, so f of x equals negative x squared minus 4x plus 1. So let's look at the leading coefficient. That's a negative 1, which means this graph is again going to fall to the left and right. So this falls left and right. Okay. Let's work on finding the vertex. So the vertex, the x-coordinate, again, is that negative of b, so negative 4 is actually positive 4 over 2 times your a of negative 1, so that'd be 4 over negative 2, which would end up giving you your x-coordinate being found at negative 2. Now let's find the y-coordinate by doing f of negative 2. Well, negative of negative 2 squared would end up giving you negative 4. Now negative 4 times negative 2 is actually positive 8, so this would be plus 8 plus 1, so you would end up getting 5. So your vertex can be found at the point negative 2, 5. So there's your vertex at negative 2, 5. Now, again, it might be easiest to go for your y-intercept. So let's find the y-intercept. Put in 0 for x, you would just get 1. So the y-intercept can be found at the point 0, 1. So let's plot 0, 1 right here. And then, of course, let's find the x-intercepts. So take that negative x squared minus 4x plus 1, set that equal to 0. It's definitely not going to factor, but we could definitely use completing the square, or if you really feel like it, use the quadratic formula. Well, this would end up giving you, if you factor out a negative 1, you would get x squared plus 4x minus 1 equals 0. So let's see, to complete the square, get rid of the 1 out of the left-hand side. So you'll have x squared plus 4x plus half of 4, which is 2. Square that, that's actually plus 4. That would end up equaling 1 plus 4. So then you'll get x plus 2 quantity squared equals 5. Which would give you x plus 2 equals both plus and minus the square root of 5. So your x-intercepts can be found at the points negative 2 plus and minus the square root of 5, 0. So let's try to plot the x-intercepts. So let's see, negative of the square root of 5, take another 2 from that, you'll get about negative 4.24. About right here. And then let's find in the positive direction, the x-intercept. So let's see, square root of 5, then minus a 2. That would give you about 0.24, which would be about right here. Alright, so let's go ahead and draw this based on all the information we've collected. And there is your graph of this parabola with your vertex located at negative 2, 5, based on all the information we've compiled. This is how you can graph these by hand. I got just a couple more of these, then we're going to move on to another set of problems where we'll actually be done graphing for the day, but they're a little bit different. Alright, so let's see here. F of x equals 4x squared minus 4x plus 21. So f of x equals 4x squared minus 4x plus 21. Let's discuss the end behavior first. The leading coefficient's positive, so this is going to rise to the left and right. So it rises left and right. Okay, let's go for the vertex. The x-coordinate of the vertex again is that negative of b, so negative 4 is positive 4. Over 2 times your a of 4, 2 times 4 is 8, so that means my x-coordinate's at 1/2. Now to find the y-coordinate, let's take f of 1/2. Well, 1/2 squared is 1/4 times 4 is 1, minus 4 times 1/2, well that'd be minus 2. And then you'll have that plus 21. So you'll end up having your vertex located at the point 1/2, 20. So at 1/2, 20, I think we'll keep the x the same, every unit worth 1, but you know what, I don't know if we're going to, let's do 4 units for 1 for the y. So 1/2, 20, so this, well, let's do 5 for 1. So 5, 10, 15, 20. Alright, so arbitrarily there's 1/2, 20. Now it's probably going to be easiest to find the y-intercept first. That's when x equals 0. Well, that would end up giving you a y-intercept of 0.21. Which we'll put right about there. Alright, now it's going to rise to the left and right, and that's your vertex, so clearly there's going to be no x-intercept. You don't even got to try to solve this. And I guarantee you, you would probably want to use the quadratic formula for this, and I promise you that you're going to definitely end up getting a negative number in your square root. So if it rises to the left and right and your vertex is above the x-axis, it's plain to see you're not going to have any x-intercepts. So you can save yourself a lot of grief there of trying to use the quadratic formula and solve all this. Okay, so there's your graph of this parabola with vertex found at 1/2, 20. I got one more for graphing, then I have a few problems of another type. Alright, so we have f of x equals 2x squared minus x plus 1. So f of x equals 2x squared minus x plus 1. Well, look at your leading coefficient. It's positive, right? So this graph is going to rise to the left and right. Okay, now let's find the coordinate of the vertex. The x-coordinate, of course, is your negative of b. In this case, negative 1, which would give you positive 1, all over 2 times your a of 2, well, that would give you an x value of 1/4. All right, so to find your y, we got to do f of 1/4. Well, that's going to, of course, equal 2 times 1/4 squared. So 2 times 1/16 is 1/8, minus that 1/4 plus 1, which would end up then giving you 1/8 minus 2/8 plus 8/8, which would be 7/8. So your vertex can be found at the point 1/4, 7/8. Kind of a messy one, 1/4, 7/8, about right there. Now, we know this graph rises to the left and right, and your vertex is above the x-axis. So clearly there's going to, again, be no x-intercepts. Now, had this been falling, there would be. But again, if you know your end behavior, that's why it's so important. You can save yourself of grief of trying to find x-intercepts that don't even exist. And now your y-intercept should just be 0, 1. That one should be pretty obvious. All right, so y-intercept is here. Let's go ahead and start graphing. And there's roughly what your graph is going to look like. For f of x equals 2x squared minus x plus 1 with a vertex at 1/4, 7/8. Alright, so that's it for the graphing portion. Now we have a few of a different type of problem. So I'm going to pull off the magnetic graphing pieces and we're going to get into these problems. Alright, let's do this here. Come on, baby. Alright. Now, let's see. Find the equation of the parabola with the given vertex and passing through the given point. I know we did some of these in Algebra 2, but these are definitely good problems. So you may also see, find the equation of the parabola with the given vertex and passing through the given point. Well, if they give you the vertex, you're always best to start out with the vertex form of the equation of a parabola. So the vertex form is f of x equals that a times the quantity of x minus h squared plus k. Whenever they give you the vertex and a point, you always want to start out with your vertex form, okay? Now, in this case, what points are they giving you? Vertex can be found at -2, 5, the point is going to be at 0, 9. So how in the heck are we going to solve this? All right, so we know, let's ignore the f of x for a minute, but let's start our equal sign. We don't know the a. We just don't know the a. Now, the vertex is always that minus h. Well, minus 2 is plus 2. So in this case, you'll have plus 2. Now for the point, they give you 0. So you'll put in your 0 for the x itself. That'd be squared plus the y-coordinate of the vertex, which is k. That's 5. You'll put in that 5. That's always your y-coordinate. Now the point has a y-coordinate of 9. So you'll substitute in 9 for that f of x, and your goal really is to solve for that a. So you're going to end up getting 9 equals a times 2 squared plus 5. Which would mean then that 9 equals 4a plus 5. So then 4a equals 4, which would just give you a equals 1. So the equation you should be looking for, what you do now once you found your a, is you take this form, that vertex form, you'll put in f of x. If it was anything other than 1, you would put that on the outside. But we definitely know that if it's a 1, you just don't need to put it outside your parentheses. F of x equals x minus the x-coordinate of the vertex. In this case, x minus 2, that's x plus 2 squared, plus your y-coordinate of 5. So in this case, the particular equation of this parabola is going to be f of x equals x plus 2 squared plus 5. And I got plenty more. I'm going to keep that vertex form up there. That'll probably help you out. Let's see. You have a vertex this time that's going to be located at the point 4, 1. The point itself is going to be at 6, negative 7. So the vertex of this particular parabola is at 4, 1. The point is at 6, negative 7 that it passes through. So let's go ahead and set this up. So ignore the f of x for a minute. Well, we don't know a again. We got to figure out a. Now, the x-coordinate of the vertex is 4, so this is definitely going to be minus 4. Now the x-coordinate of the point is 6, so this would be 6 minus 4 squared, plus that k is the y-coordinate of the vertex, so that'd be plus 1. And then the y-coordinate of the point is negative 7. In this case, you'll substitute that negative 7 in for f of x. Okay, so this will turn into negative 7 equals a times 2 squared plus 1. So this would give you 4a plus 1 equals negative 7. So 4a equals negative 8. A equals negative 2. So we found a. So this time the equation of this parabola would be f of x equals that negative 2, which is your a, times the quantity of x minus the x-coordinate of your vertex. So x minus 4 quantity squared plus your y-coordinate of 1. So in this case, you should get f of x equals negative 2 times x minus 4 squared plus 1. I got about 4 more. Alright, so the vertex of this parabola is at 1, -2. The point it passes through is at -1, 14. Alright, so the vertex of this particular parabola is at 1, -2. The point it passes through is -1, 14. So let's go ahead and start solving this here. So that point for your y, that 14, will be substituted in for f of x. That's going to equal a, which we don't know yet, times that x, which is your point. That x itself represents the point. So you take your points, you'll substitute that in for the x and y value. So x would be -1 minus your vertex coordinate of 1. So you'll have -1 minus 1 squared plus your k, which is the y coordinate of your vertex. This would all be -2. So what you should get is 14 equals a times -2 squared minus 2, which should then give you that 4a minus 2 is equal to 14. So 4a equals 16, which would have to mean that a equals 4. Now that we've identified our a, our coefficient, that means that f of x would have to equal the a of 4 times the quantity of x minus the x coordinate of the vertex, which is 1. So 4 times the quantity of x minus 1 squared minus that y coordinate of 2. So this particular parabola is going to be f of x equals 4 times the quantity of x minus 1 squared minus 2. I got 3 more. Alright, this time the vertex is located at -4, -1. The point is at -2, 4. Alright, so the vertex of this parabola is located at -4, -1. The point is -2, 4, which the parabola passes through. So for f of x, in this case, you'll take your y coordinate of the point it passes through, that 4. You'll substitute that in for that y, which is f of x. That's going to equal a, which we just don't know yet, times the quantity of that x in this case is the x coordinate of the point, which is -2, minus the x coordinate of the vertex. Well, minus 4 is actually +4 squared plus that k, that y coordinate of the vertex. In this case would be -1. So you end up getting 4 equals a times 2 squared minus 1, which would turn into 4a minus 1 equals 4. 4a equals 5. So a would have to equal 5/4. And yes, you can get fractional coefficients. So in the end, you should end up with f of x equals that a of 5/4 times the quantity of x minus the x coordinate of your vertex. So minus 4, that's +4. That would be squared. And then plus the y coordinate of your vertex, which in this case would be -1. So you should get for this parabola that f of x equals 5/4 times the quantity of x plus 4 squared minus 1. I got 2 more, and then we're done. Whoops, didn't want to do that. Alright, so the vertex can be found in this case at the point 1/2, 1. The point itself is at, wow, -2, -21/5. That one looks like a doozy. So the vertex of this parabola is at 1/2, 1. The point it passes through is at -2, -21/5. So f of x is y. So in this case, you'll substitute that -21/5 in for your y. That's going to equal your a times, all right, so the x value of the point is -2 minus the x value of your vertex, which is 1/2. That would be squared plus that k. Well, that k is 1, so this would all be plus 1. So you would end up getting -21/5 would end up equaling a times -5/2 quantity squared plus 1. So what you'll end up getting is 25/4 a plus 1 equals -21/25. So then you'll get 25/4 a would equal -26/5. All right, so then you should get that 25a. Wow, this is going to be a doozy. Would equal -104/5. Which means that a itself should equal -104/125. And yes, you can get ugly fractions like that. So in the end, f of x is going to equal that a of -104/125 times the quantity of x minus that x coordinate of the vertex, which would be 1/2, all that raised to the second power, plus the y coordinate of your vertex, so that'd be plus 1. So in this particular case, you should get that f of x equals -104/125 times x minus 1/2 squared plus 1. And I got just one more and we're done. Alright, last one. It's probably going to be a doozy, I'm not going to lie to you. Alright. Vertex is located on this parabola, -1/4, -1. The point is at 0, -17/16. Alright. So the vertex of this parabola is -1/4, -1. The point it passes through is at 0, -17/16. So f of x is y, so put in that y coordinate of the point it passes through for that f of x, you would get -17/16 equals the a, which we don't know yet, times the quantity of that x coordinate of the point is 0 minus the minus the x coordinate of the vertex, minus 1/4 is actually plus 1/4 squared, plus the y coordinate of the vertex, which would be -1. So now what you're actually going to end up with here is you'll get -17/16 equals a times 1/4 squared minus 1. So this should end up giving you 1/16 a minus 1 would equal -17/16. which should end up giving you that 1/16 a equals negative 1/16, which should just give you that a equals negative 1. So all that work for a to equal negative 1. So now your f of x is just going to equal the negative of the quantity of x minus that 1/4, so x plus 1/4 raised to the second power, plus your k of minus 1, so that'd be minus 1. So what you should get is that f of x equals the negative of the quantity of x plus 1/4 squared minus 1. So that's it for this lesson. Next lesson, we'll probably start a couple lessons on finding real zeros of polynomial functions. I think next lesson we're just going to take and review how to do synthetic division and do long division, those type of things. So I hope everyone has a great day. Take care.